Okay, Chapter 6 Practice Test. Question 1. Graph each set of data, then draw the line or curve of best fit. So for A, we have -3 and 6, which is somewhere up there. -2 and 1, -1 and -2, 0 and -3, and then we go back the other side, and then they ask you to do the curve of best fit, which would be something like that. So that's A. I'll do B in red. So we have -3, -6, which is somewhere down here, -2, -5, -1, -4, or 0, -3, 1, -2, 2, -1, and 3 and 0. So, and then the line of best fit would be something like that. So that's B. And then C, I'll do in green. We have -3, -2, -2, +6, and it keeps going up in a steep line. But at some point during its line, it's going to hop back down because we have 0 and 3, 1, so it's going to come essentially like that and keep going that way. So, which sets appear to be quadratic? A is quadratic. So we have A is quadratic, B would be linear, and C would be neither. So C. So, you have those. For 2, which of these relations appear to be quadratic? So, A and C would be quadratic. The parabola means that it's quadratic. It needs to be symmetrical over the axis. Having a 90-degree, so this is not a parabola. Parabolas have a curve to them. So, that is why B is not quadratic. And D is not quadratic because it's not symmetrical. It curves in like this. So at some given point, like here, there are 2 x values, which is not correct. If you have a normal parabola like this, at any given point, when you draw a horizontal line, it should only cross the graph once. It should only ever be a single value for x. It should not cross twice. Question 3. This table shows the times taken for a ball to roll down a ramp at different angles, and while the length of the ramp is consistent. So use a graphing calculator to do the scatter plot. My rough graph would look something like oops, something like that. So for B, find the equation of the line, or the curve. So in this case it would be a curve. You can do that on your graphing calculator. For C, is the relationship between the angle and speed best modeled by linear or quadratic relation? It would be quadratic because theoretically it would then go back up over here. It's not linear because it's not a straight line. If it were linear, it would go like this, but it curves. So it's quadratic. Okay, so for question 4, a quarterback passes the football. The equation is h equals negative 0.01 d squared plus 0.4 d plus 10, which represents the path of the ball, where h is the height of the ball in meters and d is the horizontal distance in meters that the ball travels. Using a graphing calculator, graph the ball. Again, not having a graphing calculator, it would look something like something along the lines of that. Actually, I guess it'd be more like that with this being 10. Here we go. For B, make a table of values and use it to find the second differences. So for here, you're doing it with your graphing calculator, so you already have the table of values. So I'll just explain how to do second differences. So you have your table of values with x and y. So you have a number here, like a normal table. So first you have to get the first differences, and that's going to be this number minus this number to give you your first difference, and then this number minus this number to give you your first difference, and so on. It's always the bottom one minus the top one between the pair. And then you can go on and find your second differences, which would be this one minus this one to give you your second difference, and so on. Because it's a parabola, your second differences should all be the same, because that's a sign that it's a quadratic function. Okay, question 5. The graph shows a quadratic relation. Okay, so what it has is roughly, it goes from, okay, so the graph that they've given you looks something like this. So they want to know what the vertex coordinates are. So that's right here. And that would be 3, 4. Next is find the equation of the axis of symmetry. So that's this line here. So that would be x equals 3. Identify the y-intercept. So that's this guy. So y is equal to 4. D, does the parabola have a maximum or a minimum? So it's going to have a maximum. And what is it? So the maximum value is 4, because it's this one coming across here. And then identify the x-intercepts. So the x-intercepts are x is 1, x is 5. Okay, question 6. The photograph shows the Harbour Bridge in Sydney, Australia. A grid has been placed over the photo to help you collect the data from the bottom arch. One grid space represents 50 feet. So you have your bridge, and so ignoring the numbers on here, it would go kind of like that. Again, ignoring the numbers on here. Just using it for a graph. Okay, so A, examine the photograph, make a table of values comparing the horizontal distance with the height from the roadway. So they have this as being the roadway, and this is the lower arch of the bridge. So each block or square is, so this is 50 feet. So there. So your table of values would be along the lines of, so the answers are going to be dependent on how well you could see this. But roughly counting, I have it as being, so here's 0. Oops. So I have this as being 0. I got the center point to be, roughly, as being roughly 375. And then I got over here as being 750. Because I counted 15 blocks all the way along. And then you have to multiply it by 50 because each block is then 50 feet. Yeah, so that's how I got that. So using whatever values you had, like in question 4, yeah, 4 it was, you want to calculate your first and second differences, and then just graph the relation. It's recommending to do it on a graphing calculator, just because the numbers are quite large. But that is up to you again.